name is Christina Bursill. I co-direct the Vascular Research Centre at SAHMRI, and I'm an Associate Professor at the University of Adelaide. So our key aims are to identify better ways to predict atherosclerotic cardiovascular disease. This is the fatty deposits that occur in the blood vessels of the heart and one of the main causes of a heart attack. So we look to try and find better ways to predict it early, to then identify those plaques and to work out new therapeutic targets that can help reduce its development. Yeah, I mean, there's been a couple in my life. I think the first one was when I got a postdoctoral position at the University of Oxford in their Department of Cardiovascular Research. It was such a great opportunity straight after my PhD in Adelaide to go to such a great lab led by Professor Keith Channon, an interventional cardiologist, and a group of really international people that were really hardworking. I got to work on a number of really innovative projects as well, and set me on the course for really doing research in this atherosclerotic cardiovascular disease. Another one of these was more recently, about 7 years ago, I became a chief investigator on the Centre of Nanoscale Biophotonics. It was an ARC Centre of Excellence, it was Australian Research Council, and that got me exposed to amazing multidisciplinary sort of fundamental researchers, so quantum physicists, photonics experts, chemists, and from that I did these amazing multidisciplinary collaborations and did really innovative things, and I think that was a real advance for my career and also some grant success. Cardiovascular diseases actually account for more than a third of all deaths, so that's actually all of the cancer, more than all of the cancers combined. And particularly for atherosclerosis, that's the main cause of cardiovascular disease. It occurs when we have elevated blood cholesterol levels, or particularly that LDL cholesterol, elevated inflammation, high blood pressure, for example, overweight and lack of exercise. And also, of course, smoking is a big risk factor as well. And what happens when we have a storm of these things is there's a protective endothelial lining to the arteries which becomes damaged in some way. And that means that this LDL cholesterol, this bad cholesterol, can enter the vessel wall where it shouldn't be, and that sets off an inflammatory immune response in which cholesterol immune cells start accumulating within that blood vessel, and that eventually starts to block it over time. So obviously if you block the blood vessel, you don't get blood going to all the regions of the heart, and that's the reason why you get a heart attack. One area that is underappreciated is that about 21% of people who have a heart attack or a myocardial infarction have no known traditional risk factors, and so we need better ways of actually predicting when someone might have a heart attack, so then we can give them preventative therapies in advance of something like that happening. So that's why we're working on, at the Vascular Research Centre, better biomarkers for predicting the incidence of having atherosclerosis and heart attack. Another thing I think we need to work on is once you have a heart attack, about 18% of people will go on to have a second heart attack within a year of that first one. And this is despite anyone who has a heart attack, they will go on to maximum dose therapies to lower cholesterol and control their blood pressure. So that means we need to identify new therapies that can prevent a second heart attack that are independent of the normal lipid-lowering therapies that are now currently used. I've been funded by the NHMRC, that's the National Health and Medical Research Council, and the Medical Research Future Fund. They're both government-funded agencies, as well as other philanthropic agencies like the National Heart Foundation of Australia, Diabetes Australia, as well as the Hospital Research Fund. So I'm very grateful to them. I really enjoy discovering new things. So I am a discovery scientist. I like discovering new things that are going to make a difference in people's lives, and particularly in my work to ultimately better predict and prevent people having heart attacks, which is a huge burden to their lives and their families and the community. And so it's actually trying to make a difference is the thing that drives me. I really like lab work, I really like science and discovering new things. When I was younger, I did row in the Australian junior and under 23 teams, and I've revisited the sport in the last 3 years, rowing in a masters competition. So I train pretty hard now, and I've made the masters state team that's gone on and won at national competitions. So I'm very much also a rower as well as a scientist.